When most people think about software, they picture someone just writing code, right? But what if I told you that's just one tiny piece of a much bigger, more intricate puzzle? Today, we're going to pull back the curtain and move beyond simple coding to uncover the real secrets of software engineering.
So, here's our roadmap. We'll start by looking past the code itself. Then we'll dive into the master plan for any project, the SDLC. From there, we'll get into the principles of good design, how to actually visualize them with something called UML, and then some proven solutions called design patterns. It's all leading to one place, defining what quality software really is.
All right, first things first, let's really hammer home this core idea. Software engineering is so much more than just typing on a keyboard.
So let's just ask the question straight up. Is it all just about writing code? I mean, you see developers hunched over their keyboards, typing away, and it's easy to think that's the whole job. But that's kind of like looking at a skyscraper and thinking it was all about just laying bricks.
The real answer is a hard no. It's a full-blown engineering discipline. And what that means is applying systematic, proven principles to design, to develop, and this is the big one, to maintain software for its entire life. It's about building things properly from the start so they don't come crashing down later.
Okay, so if it's a structured process, what does that process actually look like? Well, that brings us to the master plan that guides pretty much every project, the software development lifecycle, or as everyone calls it, the SDLC.
Think of the SDLC as the fundamental framework, the game plan for any piece of software. It gives you a clear roadmap with very specific phases. You start by figuring out the requirements, then you design it, then you code, test it like crazy, deploy it, and then keep it running through maintenance. It's what brings order to the chaos.
But here's the thing, there's no single best plan. On one hand, you have the classic waterfall model. It's totally sequential, you finish one step completely before you can even think about starting the next. It's simple, sure, but man is it inflexible. On the other hand, you've got something like the spiral model, which is built for massive, complex projects. It works in cycles, or spirals, where you're constantly analyzing risks with every loop.
And what if your users aren't even 100% sure what they want? Happens all the time, right? Well, that's where the prototyping model is just brilliant. You build a quick and dirty version, show it to them, they tell you what they like and what they hate, you tweak it, and you just keep repeating that loop until they're happy. It's an amazing way to avoid building the completely wrong thing.
Okay, we've got our master plan. Now let's zoom in on the actual blueprint. What are the core principles that make sure the thing we're building is actually strong, stable, and, built to last?
See, good software isn't just about whether it works. It has to be correct. It does exactly what it's supposed to. It has to be reliable, not crashing all the time. It better be efficient with your computer's resources. And crucially, it has to be easy for other developers to maintain and for people to actually use.
And to make software maintainable, you have to nail this one concept. You break your software into smaller pieces or modules. The goal is high cohesion inside each module, meaning everything in there is focused on doing one job really well. And at the same time, you want low coupling between the modules, so they're independent. A change in one shouldn't cause a domino effect. This right here is the secret to avoiding what's infamously known as spaghetti code.
This whole idea of keeping things separate scales up to the entire system's architecture. A super popular style is MVC, Model View Controller. All it's really doing is enforcing a clean separation between the data itself, what the user actually sees on screen, and the logic that connects the two. This keeps everything ridiculously organized and so much easier to work on.
So we've got these fantastic design ideas, but how in the world do we make sure everyone on the team is looking at the same picture in their heads? That's where you need a shared visual language.
And that language is UML, the Unified Modeling Language. Honestly, the easiest way to think about it is as the set of architectural drawings for software. Instead of writing pages and pages of text, you use standard diagrams to show how the system is put together. This way, everyone, from the newest developer to the project manager, is on the exact same page.
So for a library system, right, a use case diagram would just show what a person can do, like search for a book. A class diagram would show the main building blocks, like the book object and the member object. And then a sequence diagram could map out the exact step-by-step dance of how a member actually borrows that book. It's super clear.
All right, let's level up. Instead of trying to solve every single problem from scratch, what if you could tap into a library of proven, time-tested solutions from the smartest people in the field? Well, that is exactly what design patterns are all about.
A design pattern is basically a recognized, brilliant way of solving a common problem. Now, it's not finished code you just copy and paste. No. It's more like a recipe or a blueprint. It guides you toward a solution that's flexible and easy to maintain, and it saves you from having to reinvent the wheel over and over again.
And these patterns generally fall into three big buckets. You've got creational patterns, which are all about smart ways to create objects. Then there are structural patterns, which focus on how to put classes and objects together into bigger structures. And finally, behavioral patterns, which are all about how objects talk to each other effectively.
Okay, let's bring it all home. We've talked about the master plan, the design blueprint, the visual language, the proven solutions. What's the whole point of all this structure and all this discipline?
Well, the ultimate goal is actually pretty simple. It's to build high-quality software. That means software that is tough, that's easy to change and grow over time, that's fast and efficient, and, most importantly, that actually solves the user's problem. That's it. Every single thing we've talked about serves that one goal.
Ultimately, it's all about a shift in mindset. You have to see that software development isn't just a coding skill. It's a true engineering discipline that absolutely requires an organized approach, a solid foundation of principles, and crystal clear communication every step of the way.
So, I'll leave you with this to think about. Imagine a project where the customer's needs are changing constantly, like every single week. Now think about everything we just discussed. How badly could choosing the wrong SDLC model, that foundational master plan, damage not just the schedule, but the quality of the final product and its actual chance of success out in the real world? It's a pretty big deal.